Here we want to apply the gradient boosted decision trees on a problem, a data set from Scikit-Learn. Basically, we're going to use the breast cancer data set to do this project. Just as a reminder, breast cancer data set is a binary classification that has 30 features and 569 samples. So please download the IPython file and follow along to do this project together. Happy coding. To work again on the breast cancer data. Here I'm going to split our data into independent variable and target variable. All right, the next step is to split our data. So I'm going to import the split function. And then I'm going to split our data. I'm going to use random state 0, so we all get the same output. All right, now that we have split our data, let's go ahead and develop a gradient boosted decision tree. So first we need to import the classifier here. So from Scikit-Learn ensemble module, import gradient boosting classifier. I'm going to import it as GBDT to make our lives easier. And I'm going to create my algorithm as my GBDT. To get the same output, I'm going to set the random state, for example, 0. And at the same line, we can train our algorithm using our training data. Ensemble. All right. So our algorithm is ready to make prediction. So let's go ahead and make prediction on test data first. And then on the training data. To evaluate the performance of our algorithm, we need to import the accuracy score. Now we can print out the accuracy for our model. All right, so about 96% on the test data and about 100% on training data. So apparently we have overfitting problem here. To overcome this overfitting problem that we have here, we want to use the parameters of the gradient boosting decision trees to overcome this problem. So let's go ahead and create another algorithm, this time with varying the parameters. I'm going to set the random state again. Learning rate, we're going to set it as a small value, for example, 1%. You can play later with this parameters value to see which one works the best. And I'm going to also specify the max depths for the trees. All right, we can train our algorithm in the same line. So I'm going to give it the training data set. Now we're going to make predictions. So basically I'm going to copy all this and paste it here, except that I have to make these to 2. So as you see here, the gaps actually very much gone away. So right now we don't have to worry about overfitting problem compared to here. You can play out with different values of this to see what would happen. So for example, as you see here, it looks like the smaller value works better.